Hello and welcome to helpyourmath.com. In this video, we're going to look at simplifying expressions containing rational exponents. Before we get started on examples, let me offer a brilliant tip. So when we're looking at these, we're going to be looking at a base, and then we're going to have a numerator over a denominator as the exponent, right? These are rational exponents. What we want to do, or what I suggest doing, is thinking about splitting n over m up. And we can rewrite this as 1 over m times n. Right? So not violating any rules here, we can simply rewrite it as the 1 over the denominator times the numerator. And then let's see what happens when we do that. So then we have b to the 1 over m times n. And what is this? This is actually power to a power, right? Just in reverse. Usually we see this as the end result because it was given some other way. Well, if this was power to a power, then what we can do is we can focus on this first and then raising this to the power of n. I strongly suggest this, and the reason I suggest this is because almost always this base should be a perfect power of that denominator m, and so we'll be able to take the mth root and then raising it to some other power is going to be a little bit nicer. So it's making the number just way smaller for us, unless it's a fraction, in which case it's making it bigger, but that's neither here nor there. So again, my suggestion is take the fraction and rewrite it as power to a power, right? We're allowed to do this based on the properties of exponents. Okay, let's put this into action. So we have 49 to the 3 halves. This is 49 to the 3 halves. So my suggestion is rewrite this as 49 to the 1 half and then to the third. So we're taking the 3 over 2, we're writing it as 1 half times 3, and then we're saying, well, if the exponent is 1 half times 3, that's the result of a power to a power. So we're going to go back to power to a power. And now let's look at this. What is this? This really translates to the square root of 49. And the square root of 49, we know that to be 7. So this is 7 to the third, which is 343. I did a lot of steps here, and as you get more comfortable with the rational exponents, you don't have to do all of these steps. Okay, how about this one? We have 64 to the 2/3. We want to be really careful here about how we're writing this because we need to make sure that that 3 stays the denominator. So the first thing I'm going to do is I'm going to rewrite this as 64 to the 1/3, and then after we've done that, we'll square it. Well, 64 to the 1/3, this is the equivalent of the cubed root of 64, quantity squared. Well, the cubed root of 64 is 4, and 4 squared is 16. So we know that 64 to the 2/3 is equivalent to 16. Okay, pause the video and try this one on your own. How'd you do? Let's see, we have 81 to the 3 over 2. This would be 81 to the 1 half to the third. This would translate to the square root of 81, and the square root of 81 is 9. And then 9 cubed is 9 times 9 times 9, which is 729. So 81 to the 3 halves is the same as 729. Okay, for this example, we're going to step it up in a few different ways because first of all, I see a negative exponent, and second of all, I see these things. I see some variables. We are going to make the assumption for now, so we don't have to worry about this, that all variables represent positive real numbers. Okay, what's the first thing that we should do here? My suggestion, distribute the exponent. Distribute, distribute, distribute. So we're going to distribute to the negative 27. So negative 27 gets its own negative 3/4. Then x to the 9th gets its own negative. Oh, I'm sorry, I said 3/4. I meant to say 4/3. 4/3. And y to the negative 15th gets its very own exponent of negative 4/3. Now, we're going to treat the numerical base differently than the exponents. For the numerical base, let's go ahead and deal with the negative exponent. So the negative exponent is telling us take the reciprocal of the base, and the reciprocal of negative 27 is 1 over negative 27. So we have 1 over negative 27, and then this would be to the 4/3. Notice that the 4/3 stays 4/3. We don't take the reciprocal of the exponent. Okay, so then what I would do is I would think about that 3, that 1 over 3, and so this is going to be 1 over negative 27 to the 1/3, and then all of this is going to be to the 4th. The good news is that the variables are going to be much nicer than this. This is saying the cubed root, so the cubed root of 1 over the cubed root of negative 27. Is it possible to take the cubed root of negative 27? Yes, it is. We're going to end up with 1 over negative 3, and then we're going to raise that to the 4th power, and we're going to end up with 1 over positive 81. Whew. Okay, so basically the whole point of this is that negative 27 raised to the negative 4/3 results in 1 over 81. So we have 1 over 81. What else do we have? What we're going to do for the variables is because they have exponents, right? We have x to the 9th to the negative 4/3. This is power to a power. We're going to multiply those powers and see what happens. So we have 9, which I'm going to write as 9 over 1, times negative 4 over 3. A negative times a positive is a negative. And we're going to simplify before we multiply. Now that the denominator is all 1s, we can go straight across and we get negative 12 over 1, which is negative 12. So x to the 9th to the negative 4/3 becomes x to the negative 12th. Well, wait, we don't want a negative exponent. What does that mean? That means that's going to be x in the denominator. So going back up here to my fraction, we're going to have an x to the 12th in the denominator as well, right? Because that should have been x to the negative 12th, but in order to make that exponent positive, it gets moved to the denominator. Okay, last but not least, our base y. So y, we have negative 15 over 1 times negative 4 over 3. A negative times a negative is positive, and simplifying before I multiply, I have 5 times 4 is 20 over 1, which is 20. That would be y to the 20th. That has a positive exponent, so it goes to the numerator. So I don't need the 1 in the numerator. We can put y to the 20th in the numerator. And so simplifying this bad boy, we end up with y to the 20th over 81 x to the 12th. Okay, you try this one. Pause the video, see how you do. This one was a little bit nicer, maybe. Okay, so what are we going to do first? We're going to distribute the exponent. That's 32 to the negative 2/5 times n to the negative 10th to the negative 2/5. What does the negative mean? It means take the reciprocal. So we would have 1 over 32 to the 2 over 5. And then I'm going to split up that exponent and I'm going to consider it to be 1 over 32 to the 1/5. And then we're going to take that result and square it. So now we're looking for the 1/5, or 1 over 32 to the 1/5 power. That would be the 5th root of 1 over the 5th root of 32. And then all of this would be squared. Well, the 1/5 power of 1 is 1, and the 5th root of 32 is 2. This would be 1 over 2 squared, which would be 1 over 4. So here we end up with 1 over 4. And then what about n to the negative 10th to the negative 2/5? This is power to a power, so we're going to multiply the exponents. That would be negative 10 over 1 times negative 2 over 5. Negative times negative is positive. And then we can simplify before we multiply. We get 2 times 2 is 4. 1 times 1 is 1. That would be 4. We have n to the 4th. N has a positive variable, a positive exponent, so it goes in the numerator. This becomes n to the 4th. So we have n to the 4th over 4. What is going on with this example? There's a lot to uncover here. Let's do this step by step. So the first thing I would do, I see the negative exponent that's on the outside, this one right here, and this one means take the reciprocal of everything inside the parentheses. So I might just go ahead and do that first. That would just move everything from the denominator up to the numerator, and everything that's in the numerator down to the denominator. Notice that when I do that, everything stays the same. So that x to the negative 9th is still x to the negative 9 because I use the negative from the outside of the parentheses. Now what I can do is I can distribute the 2/3 to all 4 bases. So this would give me 125 to the 2/3 times y to the 6th to the 2/3 over 27 to the 2/3 times x to the negative 9th to the 2/3. If you want to take care of that negative 9, you could do that now, or we can do it later. I will just kind of do each one piece by piece, so I'm going to just leave it for now. Starting with 125 to the 2/3. So 125 to the 2/3, we want to think about rewriting this as 125 to the 1/3 quantity squared. And what's 125 to the 1/3? That's the cubed root of 125. The cubed root of 125 is 5, and then 5 squared is 25. That 25 wants to be exactly where that 125 originally was, and so that's going to be in the numerator of this fraction. Moving on, we have y to the 6th to the 2/3. This is power to a power, so we're going to multiply the powers. This would be 6 over 1 times 2 over 3. Simplifying before I multiply would give me 2 and 1, and that would give me y to the 4th. Y to the 4th is positive. It would go in the numerator as well. How about this 27 to the 2/3? So 27 to the 2/3. I'm going to break up that fraction and think about that as 1/3, 27 to the 1/3 squared. This is the cubed root of 27. The cubed root of 27 is 3, and then 3 squared is 9. 9 has a positive exponent, so it wants to go where it was originally, which is in the denominator. So we're going to put 9 in the denominator. And then last but not least, let's deal with this x to the negative 9th to the 2/3. I'm going to come all the way up here. So x to the negative 9th to the 2/3. This is power to a power, so we can multiply our exponents. That would be negative 9 over 1 times 2 over 3. And we can simplify the 3 and the 9, leaving us with x to the negative 6. Now, this x to the negative 6 would replace this right here. It has a negative exponent, which means we want to move where it is. It's in the denominator. It's going to have a positive exponent in the numerator, so it's going to join the 25 and the y to the 4th to be in the numerator. And this would be our completely simplified version of this example. Just a few more examples, and these are going to get a little bit different. We're going to actually deal with some operations here. So we want to add these two numbers. We can't add them as they are because they have different exponential parts. Let's see if we can simplify these. So what's 25 to the 1/2? Well, 25 to the 1/2 is equivalent to, this would have an index of 2, that would be the square root of 25, which is 5. So we can replace 25 to the 1/2 with 5. 27 to the 2/3, I think we just did this on the last slide. I would think about this as 27 to the 1/3 quantity squared. 27 to the 1/3, that's equivalent to the cubed root of 27. The cubed root of 27 is 3, and 3 squared is 9. So what this is really asking us to do is add 5 plus 9, which is 14. Hey, that wasn't so bad. How about this example? I think these should probably be in parentheses. It looks like kind of just the numerators are being raised to the 2/3 and the 1/2, but let's put those in parentheses. So we want to take 1/8 and raise it to the 2/3 power. 1/8 to the 2/3. Well, this would be 1/8 to the 1/3, and then we would square that. So this would be the cubed root of 1/8 quantity squared. This would be, I'm just going to write the 1, right? Because the cubed root of 1 is 1. And then the cubed root of 8 is what? Oh, that's 2. So this ultimately becomes 1 over 2 squared, which is 1/4. And notice that I show a lot of steps here. You can probably skip some of these steps as you get more and more comfortable with these, but I just like to show everything. Okay, how about this 1/4 to the 1/2? So 1/4 to the 1/2. Oh, that's just the square root of 1/4. So the square root of 1/4 would be the square root of 1 over the square root of 4, which would be 1/2. So what we really want to do here is add 1/4 to 1/2. If we're going to add fractions, we need a common denominator. The common denominator between 4 and 2 would be 4. I'm going to multiply the 1/2 by 2 over 2. That would be 2 over 4. So this would be 1 plus 2 over 4, or 3 over 4. And in our last example, we have a little bit of stuff going on here. First, I'm going to distribute that exponent of negative 1/3. So we have 64 to the negative 1/3, and x to the 6th to the negative 1/3. 64 to the negative 1/3, so the negative part of the exponent means we want the reciprocal. That would be 1 over 64. And now this would be to the 1/3. So this would be the cubed root, right? 1/3 is the same as the cubed root. And again, the cubed root of 1 is just going to be 1, so I'm going to kind of ignore that for now. The cubed root of 64 that would be 4. So we have 1 over 4. Okay, how about x to the 6th to the negative 1/3? Well, x to the 6th, that would be power to a power. So this would be 6x to the 6th times negative 1/3. Put 6 over 1. We have a positive times a negative, so that would be a negative. And this would be x to the negative 2, indicating to us that that factor of x wants to also be in the denominator, so we end up with 1 over 4x squared is what happens when we simplify this. 1 over 4x squared. Okay, how about 49x to the fourth to the negative 1/2? So first I'm going to distribute. This would be 49 to the negative 1/2 times x to the fourth to the negative 1/2. The negative part of the exponent means take the reciprocal. So this would give me 1 over 7. Sorry, let's try that again. I'm getting ahead of myself. 1 over 49 to the 1/2. This is saying take the square root. The square root of 1 is 1. The square root of 49 is 7. Dealing with the x, the factor or the base x, we have x to the fourth times negative 1/2, right? Power to a power, we multiply. This would give us x to the negative 2. Well, that just means that x squared wants to be in the denominator, so it's going to join the 7. So we would say plus 1 over 7x squared. If we want to combine these into one single number, we need a common denominator. So we're going to work down here so I have a little more space. The common denominator, we have a factor of 4 and a factor of x squared in the first fraction. In the second fraction, we have a factor of 7 and a factor of x squared. So our least common denominator needs to have a factor of 4, a factor of x squared, and a factor of 7. 4 and 7 don't have any common factors besides 1. So we need 28x squared. Here we're missing the factor of 7. Here we're missing the factor of 4. And so we would end up with 7 plus 4 over our common denominator, 28x squared. And we would end up with 11 over 28x squared. These have been examples of simplifying rational expressions. Thank you for stopping by.